Deep conversation on time travel.
Welcome, everyone, to today's fascinating discussion on time travel. We are honored to have with us an expert on the subject, Professor Albus Gluner, who will help us unravel the mysteries of traveling through time. Let's dive straight into it. Professor, what exactly is time travel?
Thank you for having me. Time travel, in simple terms, is the concept of moving forward or backward through time, just like we move through space. While it has been a popular theme in science fiction, modern physics, particularly Einstein's theory of relativity, suggests that time travel may not be entirely impossible.
That's intriguing. Can you explain how Einstein's theory connects with time travel?
Certainly. According to Einstein's special theory of relativity, time is not absolute, but rather a dimension intertwined with space, forming what we call space-time. This leads to a phenomenon known as time dilation. When an object moves closer to the speed of light, time slows down for that object relative to an observer at rest. This means if an astronaut travels near the speed of light and returns to Earth, they would have aged much less than people who remained on the planet. This is one form of forward time travel, which has already been confirmed by experiments using atomic clocks on fast-moving spacecraft. Additionally, general relativity suggests that gravity itself can affect time. A stronger gravitational field slows down time relative to a weaker field. This effect has been observed in GPS satellites, where time moves slightly faster compared to clocks on Earth due to weaker gravity in orbit.
That sounds like something straight out of science fiction. Speaking of which, how does time travel work in sci-fi compared to real physics?
Great question. Science fiction often takes creative liberties with time travel. For instance, in movies like Interstellar, time dilation plays a major role. In Back to the Future, time travel is depicted as a result of breaking the laws of physics using a flux capacitor. While these ideas are fictional, some theoretical physics concepts like wormholes and black holes suggest potential methods for time travel.
You mentioned wormholes. Are they real? Could we travel through time using them?
Wormholes are theoretical passages in space-time that could connect distant points in space or even different points in time. General relativity suggests they could exist, but none have been discovered yet. If a wormhole were to exist, and one end moved near the speed of light while the other remained stationary, it might create a time loop, allowing travel into the past. However, the physical feasibility of such a phenomenon remains uncertain.
That is amazing! What are the biggest challenges to time travel?
The most notable issue is the grandfather paradox. For example, if you travel to the past and prevent your grandfather from meeting your grandmother, you would never be born. But if you were never born, how could you have traveled to the past in the first place? Such paradoxes lead physicists to propose theories like the Novikov self-consistency principle or the multiple universes theory.
Does that mean alternate universes might exist?
Yes. According to the many worlds interpretation of quantum mechanics, every possible outcome creates a new universe. So if you were to change the past, it would not alter your original timeline, but instead create a new parallel universe.
In your opinion, will humanity ever achieve time travel?
Forward time travel, as supported by relativity, is already proven. However, traveling to the past remains theoretical. Future discoveries, such as finding tachyons or other exotic particles, could unlock new understandings.
Thank you for your incredible insights, Professor, and for joining with our media program. So we are again meet in our program. You are goodbye.